Hey everyone, this is Matt. Welcome to another Activate tutorial on creating games with GameSalad. Hopefully you're familiar with the drill by now. This is an intermediate level tutorial, so I expect you to have some familiarity with GameSalad already. Make sure you've gone through the beginner material. This is Operation Green Clean. This is the game we'll be making today. This is an interesting game for unique movement systems, and that's what we'll be exploring. So make sure you have the GameSalad software and the folder of resource files for Operation Green Clean. And let's go ahead and get started. We have a lot to cover, so I'm going to move pretty quickly. This is, of course, a video companion to the PDF copy of the tutorial, so of course you can make reference to that as well. But let's take a look at the game and see what we are going to make. So, this is a game probably very similar to something you've run into in real life, hopefully with roaches that are not quite this big, but you've gone to a park and there's litter, and you just feel sad at the state of humanity because there's litter in the park. So in this case, you're a hero and you're going to do something about that, and you're going to be clicked to told where, well, some higher power is going to click to tell you where to go. And then you can pick up the trash bags and avoid the pests and try to clean up the park. Of course, if you run into the pests, these are really nasty cockroaches, and so they get you, and the game restarts. But take a look at the movement. Hopefully you've played this on the website. Make sure you do. But you'll see there's this interesting system where we click to set a destination, and the hero moves there. And then we can, if we want to, hold the button down, and he'll change his path to follow the mouse. And if he runs into the mouse, then we can still move it off and keep it moving. So let's set about making this. First thing you'll need to do, of course, is open a blank project. Here's mine. I'll call it Operation Green Clean for obvious reasons. And I'll choose the platform, in this case, GameSalad Arcade. And click on the Scenes tab up here, and then double click on Initial Scene, and we can get started. Maybe we already got started. We can start making the game. And the first thing we should do is import the images from that resource file folder. So you'll want to click the Images tab in the library, and then find that folder, and look for these images. And we're not going to need all of these. There are extra ones if you want them, but I'm just going to use a few of them, or 6 of them to be precise. So I'll take the hero and the fly and the dirt and the grass and the roach and the trash bag. Drag those into that images section of GameSalad. And now there they are. But I can't use them in the game yet. I have to make actors with those images attached because everything in GameSalad has to be an actor. And so I can do that very easily by choosing all of the images and then dragging them into the actors section of the inspector. And now here are my actors with their images attached. So now we can start putting elements into the game. And since that movement system for the hero is so complex, that's probably a good place to start so we can get that out of the way. So we'll need a hero. And I dragged a copy into the scene. Now, how do we want to do this? So let's think about how this works. I can click, and the hero moves to where I clicked. And notice also if I click and release and then I move the mouse elsewhere, then he doesn't follow the mouse, he goes to wherever I clicked because he remembers it. But if I click and hold, then he will change his path to follow the mouse until I release, and then he'll go to wherever I release the mouse at. So how do we start making this? Let's take this one step at a time. First thing is probably to make him follow the mouse. So we can open up the hero prototype, there it is, and give him his first behavior. Now, if you've worked through the previous tutorials, which you should have, then you'll be familiar with the move behavior. But in this case, if we run that, of course it just moves the hero off on his own. He's not under our control. And although we don't see it because he goes off screen, he keeps moving forever. And that's not what we want in this case. We want him to move to a specific place. So we don't want the move command. In this case, we want move to. And we can set our destination position. This is in the x-axis, so you can see the arrow pointing to the right, and this is in the y-axis, that's the arrow pointing up. Where should his position be? Well, if we just leave it on the default 0, 0, then he moves immediately to the lower left because that's where the 0 point on the x and y axis is. But we don't want him to move to a specific point. We want him to move to wherever the mouse is. And the trouble is, what are the x and y coordinates of the mouse right now? Well, you probably have no idea, and I certainly don't have any idea. We don't really know where the mouse is in terms of its coordinates. But we don't have to because GameSalad does know. And it tracks it for us and we can use that. How do we do that? Well, we have to set an attribute in the expression editor. So what does all that gibberish mean? It means if you click this letter E, it will open the expression editor. And in that we can click this arrowhead, and that'll give us the attribute browser, which lets us look through all the attributes we have available. And we can choose the category of devices. And what that does is it lets us get data from the computer's hardware. This is data that GameSalad tracks for us, and we can just use it. So one of the devices is the mouse. And we can choose position, that's what we're interested in, and then double click on X. So there it is. The mouse's X position. That's an attribute that's built into GameSalad, and it automatically updates with whatever the X position of the mouse is, so we don't have to know what it is. So we can click the green check mark, and there it appears as the destination X coordinate. So obviously we want to do the same with Y, and it works the same way for the Y coordinate. Devices, mouse, position, Y. Now, let's try that. And that works. And you can see he zips around the scene trying to get to the mouse. He's trying so hard. He just can't quite get there. He can't quite do it. He can't quite. Oh, he did it. So that's good. Good for him. Good for us. We've made progress. But this is not where we really want to be because we're not clicking, right? We want his movement to be dependent on our clicking. Right now he's just moving to follow the mouse by default. It doesn't matter if we click or not. So that's no good. And then also if he reaches the mouse and then we move the mouse off him, he doesn't start moving again. So we need to solve both of those problems. How are we going to do that? Let's go back and look at the logic of our behavior. We're telling him to move to the mouse's X and Y position. The trouble is, actually we're not having trouble just yet because first what we want to do is make him move on the click. So before, hold that troublesome thought, we'll come back to that. What we need to do right now is set a condition for clicking. And whenever you want to set a condition in GameSalad, you need to create a rule. So I'm going to create one. And now I can decide what the condition should be. And in this case, we don't care about the mouse position, but we do care about the mouse button. And down is the default, that means the button is clicked. And this just means that the actor, the hero, is paying attention to the condition of the game to see if we do this thing, which is clicking the mouse. What do we want to happen when we click? We want to trigger that movement behavior, so we can drag that inside the rule. So now it should only happen when we click. Let's try it. And you'll see if I move the mouse around and I'm not clicking, he doesn't go anywhere, he's just sitting there. But if I click and I hold, then he goes to the mouse, which is great. He's moving on the click. But you'll notice I said hold the button. If I just click and release right away, he only moves a tiny bit. He's like, I could go over there, but I don't really feel like it, so I'm just going to take a little step just to show you I'm trying, but I'm not really going to go all the way. Why is he doing that other than to be a nuisance? He's not actually being a nuisance. It's all logic. Well, I think he's a nuisance, but that's not the technical reason. The technical reason, if you look at this, is this movement behavior requires this condition to be true. So it's only the case that he moves if the mouse button is down. And as soon as we release the button, that condition is no longer true. So he doesn't move. Now, you might think because the behavior is called move to, rather than say move toward, that he should go all the way to the mouse. But he doesn't. The movement still, it's only going to run if this condition is satisfied. And that's not helpful to us because we don't want to have to click and hold the button down. That's frustrating. That's not good. Fortunately, there's this option called run to completion. And this has a checkbox, and we can check it. And what run to completion means is if this behavior starts, then it should finish, regardless of whether the condition remains true. Let's try it. Now, I'm going to click and release right away, and he still moves to the mouse. And that's true whether I hold the button down or if I release the button. It doesn't matter. Why is that? Well, we've clicked, and that's meant that when we clicked, that set this condition to be true, and so that triggered this behavior to start. And then because we checked this box, the behavior is going to go ahead and finish, even if we stop clicking, and so this is no longer true. So this is good. We're making progress, but this is still not ideal. I mean, he can now, if he reaches the mouse and then we click somewhere else, he starts moving again. But if we click and then we move the mouse around, then he changes his path. And that's different than here, where if I click and move the mouse, he keeps going where I clicked. So here, unless I hold the button down, in which case he changes his path to follow the mouse, if I don't hold the button down and I click, then that is a destination that we've set. We've clicked and we've set a specific location for the hero to reach. And that's not what we're doing in our version, at least not yet. Even though we're clicking somewhere on the screen, obviously, because we have to, it's not really setting a destination. If I click in the lower left, I'm not, ooh, there we go. If I click in the lower left, I'm not really telling him to move to the lower left. I'm telling him to move to the mouse. And the mouse happens to be in the lower left, but if I click and then I move the mouse, then he's going to move too, because he doesn't care about where I clicked. All he cares about, the only thing that clicking does, is moving him to the mouse, wherever the mouse is. So that's no good. We need to change that. How are we going to change that? Because if you look at this, we're giving him as the goal the X and Y position of the mouse. And those are built into GameSalad to track the mouse's position. And we can't control them. They are always going to change as the mouse's position changes. There's nothing we can do about that. So that means if we want to set a specific destination that doesn't change, even if we move the mouse again, we can't use these directly. But we still need to use them. And we need to take note of where we clicked. So if you could think of it as jotting down a note to ourselves or to GameSalad, that's sort of the analogy. Where when we click, we want to record where we clicked and store that somewhere, and then tell the hero to move to that stored location. And then it doesn't matter if the mouse position changes again, because he's not moving to the mouse anymore. He's moving to the stored location, and that stored location changes to wherever the mouse is only when we click. So let's talk less and put that more into practice so you can see it in action. So go over to the hero's list of attributes. We can go ahead and create them here. And you can click the plus button to create a new attribute. And what we want to do is store the X and Y positions. So those are integers, which means we need to create integer attributes. And there's our new one, helpfully called new attribute, which isn't really very descriptive, so we can double click on that and change it to something else. And I'll call it move X. So this will be the goal position in the X axis. But we need the one for Y as well, so we create another one, which is also an integer. And double click on that. Call that move Y. Obviously, you can call them whatever you want. The name doesn't matter. It's just for you. Now, what are we going to do with these? Well, we need to use them to store the position of the mouse when we click. We already have a condition for clicking, so we can use that, but we need to change their value. And for that, we can use the behavior called change attribute. So I'll drag that into this rule. What attribute do I want to change? I want to change the ones that we just made. So remember that I created move X and move Y in the list of attributes belonging to the hero specifically. So I need to choose hero and then scroll through his attributes until I get to move X and move Y, and I'll choose move X. Now what do I want to change that to? Well, I want to change that to the mouse's X position, which again is devices, mouse, position, X. This is probably very familiar at this point. And then I need a copy for the y-axis as well. So in this case, I will change hero move Y, change that to devices, mouse, position, Y. So what is the overall logic here? The logic is check if the mouse is clicked, and if it is, change the value, the current value of move X to the mouse's X position, and change move Y to the mouse's Y position. Now, that's not going to help us unless we also update this rule, because now we don't want to move to the mouse's X and Y position. That was what was causing problems before. Instead, we want to move to the attributes that we just created. So I'll choose hero, move X, and here, hero, move Y. Same idea. We're moving them to a specific point. And it is a point that corresponds to the position of the mouse. But now, there's only that matching when we click. Because when we click, then it copies the value of the mouse's location into our move X and move Y attributes. And then even if we move the mouse after that, and so the X and Y position of the mouse change, move X and move Y do not change. They stay the same as when we clicked. And they stay the same until we click again. So then by moving the hero to move X and move Y, it frees him from following the mouse. Let's try that. And it works. You can see if I click and then I move the mouse, he still goes to wherever I clicked. He no longer follows the mouse. So this is great. And just seriously take a moment and pat yourself in the back and think about what we just accomplished, because this is a pretty slick and sophisticated movement system for especially considering how little work we had to do to get here. It's a little abstract because we're storing positional information in attributes we created and all that, but still it's fairly simple, and yet it allows us to do this pretty amazing thing, which is to record a position that we clicked on screen and then move this character to that position. So this is very cool, and if you've ever played a game like a strategy game perhaps where you're moving military units, or a point and click game where, I mean, this is pretty much what this is, but a point and click adventure game where you're clicking to tell the hero where to go, well, we've just made that. So go us. We're still not quite where we want to be for the finished version, because if you recall, in the finished version you can click and he goes to the location just like we've got, but we can also click and hold, and then he updates his position to follow the mouse. So it's sort of like what we had before, but now it only happens if we hold a button. It doesn't happen if we don't hold a button. And then also if he runs into the mouse and then we move the mouse off him again, he starts moving again. We don't have those aspects yet. We need those. Or we're going to choose to have them anyway. I'm in charge of this tutorial. So how do we bring that off? Well, why don't we have that stuff already? Why isn't it the case that when we hold the button down, he updates his path? If you look at the logic here, you might think that we should. Because this rule says, if the mouse button is down, change move X and move Y to the mouse's location. And the thing is, when we click and hold the button, the mouse button is still down. So you'd think that it should be changing move X and move Y to the new mouse position all the time, as long as we're clicking. But the thing to realize is that GameSalad considers a click and release to be a single event. That's all part of one mouse click, if you will. And that's true whether I click and release right away or I click and hold the button down for a few seconds and then release. Both of those are considered a single event by GameSalad. The click is the pressing down is when it starts, and the letting go is when it ends. And this change attribute behavior, it only happens once per event. So even though we're clicking and holding the button down, it's not running this change attribute behavior multiple times. It's only happening the once, because we only press the button down the once. And then we'd have to release the button and then click it again for this to update again. So that's no good. Fortunately, there is a solution. And that is another behavior called constrain attribute. It's very similar to change attribute. In fact, if I drag a copy in, you'll see the structure looks pretty much the same. The difference, as you can see here, is that this behavior continuously updates. So constrain attribute, it runs as frequently as it can. Even if it's just a single event, it'll run multiple times. That's exactly what we need. So now I'm going to set up 2 copies of constrain attribute. And this setup is going to be identical to how we set up change attribute, because it's doing the same thing. It's just doing it multiple times instead of once. So I'll just go through that quickly. Hero, move X, change it to devices, mouse, position, and X. Oops. X. No, catastrophe. There we go. All right, and then also change hero, move Y. Change that to devices, mouse, position, Y. Same as up here. Difference, it's constrain instead of change. And that makes all the difference in this case. So we don't need these 2 anymore. They're no longer relevant. So I can either delete them with the X or I can turn them off. And I'll turn them off just to leave them on there. They were kind of friendly. So let's try this out. Now it's the same if I click and release right away. That's good. But now if I click and hold, it works. He changes his position to follow the mouse. Why does he do that? Because when I click and hold, it's repeatedly updating the goal position of move X and move Y to the changing position of the mouse. So that's awesome. We're still not done. I know. So many steps, and we still have one more, but it's pretty easy. The thing is, if he catches up with the mouse, and now I need to do it again. If he catches up with the mouse and I'm still holding the button down and then I move the mouse off him, he doesn't start moving again. And that's perplexing. But there's a pretty good and simple explanation for it, and again, it's logical. Look at the rule. We told him to go to a specific position when we click, which is move X and move Y. But those are just names for a specific coordinate point on screen that has an X and a Y position. We told him to move to a point. And the thing is, if he reaches the mouse, he has moved to that point. He has obeyed our order. And even if we then move the mouse off him, and so we're changing both the mouse's position and also move X and move Y because we're still clicking, so they're still updating, it doesn't matter because he already did what we asked him to. We didn't ask him to move to the mouse again. We didn't ask him to move X and move Y again. We only asked him once, and he did it. So he's not doing anything wrong. We just need to update our logic. How would we do that? Well, there's not really an equivalent to constrain for move to. There's no constrain move to or move to repeatedly or anything like that. But what we can do is create a rule. And what we can do is we can check and see, if the button is down, so he should be moving, we can compare where he is with where he should be, the goal. And if it's different, we can move him there. So how would that work? It would work like this. We create a rule. And in that rule, instead of checking for an event, we're going to compare the value of an attribute to another. So in this case, we'll check for which attribute? Well, now we're not going to use MoveX just yet. We're instead going to check the hero's current position. And that is built in just like it was for the mouse. So we do hero and then position and then X. And we don't want to check if it's equal to something. Oops, sorry about that. We don't want to check if it's equal to something we want to check and see if it's not equal to something, which is the goal, move x. So now, of course, I just do hero and move x. And we also need one for the y coordinate, so I'll set that up the same way, just with y this time. Hero position y is not equal to, remember to change that, that's the equals with the slash through it, not equal to hero move y. So what is this saying? This is saying check if his current position in x and y axis is not equal to the goal position, move x and move y. And then one other thing we need to do is go up here and change all to any. And the reason we have to do that is that if it says all, then he has to be in a different x and a different y position before this will trigger. But he might be in the same x position as the goal and just be above it or below it, so he has a different y position, or vice versa. And so we need to have him move only, we need to have him move if there's any difference at all between his position and the goal. So what should happen if there's a difference? Well, then we have him move to the goal. So we can move that into this rule. And this whole rule, we still want him to only move if we click. So all of this needs to go inside that rule checking for the click. So that's a lot, I know. Now we have rules inside of rules inside of rules, sort of like that movie Inception. But let's talk about what it does. This rule is saying, first of all, check if the mouse is clicked. Have we clicked? Oh, we did click. Okay. So because we clicked, we'll update. We'll store the mouse's position in the x and y axis in attributes we created called move x and move y. And then after we store them, we'll check and see if the hero's current position is different than that move x and move y. And if it is, then we move him to move x and move y. Let's try that out. It's pretty complex, but I think we've got it. So I can click, and he moves there. That's fine. I can click and hold, and he follows the mouse. That's fine. And then if I continue to hold and let him catch up with the mouse, and then I move off, he starts moving again. And if I release, then he goes to wherever I release the mouse at. So that is it. Great job. Just take a deep breath. I'll do the same. And yeah, I feel good. We just completed the duplication of that movement system from the finished version of the game. And again, this is a pretty sophisticated system. So be proud of yourself. But don't rest easy. This is just the beginning. Although it's only it's the hardest part for sure. So it's pretty smooth sailing from here. Now that we've got a moving hero, we need to give him something to move through, because it's just a black void and that's not very fun for him or for us. So let's start building out the scene. Oh, one other thing. We'll probably need to give the hero more behavior at some point, and you may notice it's a little cumbersome to scroll through all of this because it takes a lot of space vertically. So you can take advantage of this little arrow. It's in the upper left of pretty much everything behavior-wise in GameSalad. You can click that and it will hide everything inside. And if you need to see it, you just click on it again. And that's great. That's a great way to get things out of the way so you can add more without trouble scrolling through things. The one downside is that now I don't really know what's inside because it just says rule. I'd have to open it to see what's inside. But I can rename this just like anything else. I can double click on rule and I can call it movement. And now I know, because I've left a note for myself, what's inside this. So let's start building this scene. Probably we want to give this park some grass. And we have a grass actor right here. So I'll drag a copy in. And you'll notice right away, look how pathetic and tiny this is. Look at that. That's just sad. I don't even want to call that grass. Can you imagine trying to make a bunch of copies of this and fill up the whole black rectangle with these guys? Fortunately, you don't need to. The image, I happen to know, is a certain size, which is 32 by 32. And right now, the actor, it's a lot smaller than that. We can make it the same size as the image. And the way we do that is by opening up the actor. And then look in this list of attributes, you'll see there's one for size. And I'll open that up with the arrow. And instead of this, I'll change this to 32. And I'll change this one as well. So now the dimensions of the actor are 32 by 32, which is the same as the image. And now if I click back, check it out. It's still just one, but now it's a much more reasonable size. Now the thing is, even at this size, it still seems like it would be pretty tedious to, whoops, that's not what I wanted to do. I meant to drag this one. It's still going to be pretty tedious to, make lots of copies of this and fill up the screen that way, but we don't need to, because another trick we can do is select the grass and then drag these arrows, these circles on its outside, and we can stretch the actor that way. And I can stretch it to fill up the entire scene. You'll notice, by the way, I'm going beyond the bounds of the black. That's okay. That just means that what's outside the black won't show up on the game screen. That's not a problem. So great, we're done, right? No. Look at that. That's ugly as all get out. Super grainy and pixelated and low resolution. Terrible. Nobody wants to play in that grass. Just leave it to the roaches. But why did that happen? Well, remember, this image is 32 by 32. And we don't quite know what the size of this actor is now, but it's way bigger than that. So that single image, it's been stretched to fill a much larger space than the image is by default. And so it's distorted for that reason. But we don't need to leave it that way, because remember that the image, as we've seen, is different than the actor. The actor by itself is just a blank white square. The image is a cover for the actor. Because of that, we have options for how it covers the actor. So let's open up the grass again and scroll through the attributes down to the bottom, and you'll find one called graphics. This is actually a category, and you can expand it with the arrow. And look at what we have here. We've got a bunch that we don't really need, but here we have what's called horizontal wrap and vertical wrap. These control how the image covers the actor. And by default, they're set to stretch, which is the problem that we had. Just one copy of the image distorted to fill the bounds of an actor that's way bigger than the image. But we don't have to leave it in stretch. We can also choose other options. And in this case, we want to choose tile. So I'll change that for both horizontal and vertical. Now what does that mean? I'll show you what it means. Click the back button. And look at that. It's so much better. I don't even have words for how much better it is. It's nice and clean and crisp. Looks like a tennis field or a golf. Well, tennis isn't really a field, is it? A tennis court or a golf course. What just happened? Well, if you click on this, you'll see it's still a single actor. It's not a bunch of copies of the actor. It's still just one. But the image has been tiled. And what that means is there are lots of copies of the image, and they're all next to each other, as many as needed to fill up this actor. And that'll be true even if we stretch it further. You can see it still keeps its quality. Now it's too big for the bounds of the screen. That's what tiling is. And this kind of image is perfect for tiling because it looks good no matter how you stack the images next to each other. You can tile any image, but they're not all going to look good. Like the fly would look really bad if you tiled it. But the grass is perfect. It's intended for tiling. And so there we've covered the entire area with grass with minimal effort by using tiling. So it's very powerful, and you should make sure to use it. Now, you may wonder what happened to the hero. And the answer is we covered him with the grass. That wasn't very nice of us. But really what's going on is GameSalad draws things in the order that you added them to the scene. And so we added the grass after the hero, and so now the hero's underneath the grass. But we don't need to leave it that way. You can alternate click on the grass, and you get these options. And I'm going to choose Send to Back. And you'll see the hero has now appeared. What does that mean? Well, that means GameSalad uses what's called layers. If you've used any graphics programs, you're probably familiar with layers already, but layers just mean what things are on top of what. And by choosing Send to Back, I told the grass to move to the back of the layer so that everything else is on top of it. So keep that in mind. If you get things that are not in the right order in terms of what's on top of what, you can change the layer options. So now what? We have our grass, we have our hero, but there's nothing for him to do. He can move around the grass. He's like, do, 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 do. He's having a great time, but there's no game here. So we need to add a game. And if we go back and look at the finished version, we'll see that we need dirt paths, we need trash bags that we can collect, and we need the roaches to menace us, as only roaches can do. So let's start with the dirt paths and the trash bags. I'm going to make a really primitive level just for speed's sake. You should, when you're making a level, take more time and make it nicer than this. But I'll go ahead and put a couple of trash bags in, and then dirt. And you'll see with the dirt, it's the same problem as with the grass. It's tiny, so we can use the same tricks, which is to change the size to 32 by 32. And then also I'll set the tiling. So graphics, horizontal wrap tile, vertical wrap tile. There we go. And I'll just go ahead, I'll go ahead and move that over here and then make a quick square around the trash bags. Definitely make your levels more interesting than this. This is a very dull level, but it should serve our purposes. Another trick is if you click an actor, and you can then use the arrow keys to move it a tiny bit with great precision. That's very useful, especially with smaller things. All right, that'll do. See, now I'm trying to get it all perfect. This is the problem with doing this live. Yeah, good enough. Okay. And so let's check it out. Here's our dirt path. Here are our trash bags to collect. Now if I run the game, here's like, I'm going to get those trash bags. Oh, I just ran under the dirt. That's weird. The dirt is floating in the air. It's not actually floating in the air, but it's the same problem with the layers as before. So now, because we added these later, so they're on top of the hero. So now I'll right-click on the hero and choose Send to Front. I move the grass to the back and move to the hero to the front. And now if I run it again, now he's on top, and so he can walk on the dirt, but he just passes right through the trash. And that's because we haven't told anything to happen. We haven't told GameSalad to do anything if we collide with the trash. As far as it's concerned, it's just a picture. So let's do something about that. And it makes sense to just destroy the trash when the hero walks over it, because that's how it should work in reality, although it doesn't. But this is a game, so we can do whatever we want. Plus, he's supposed to be collecting it, so it's sort of the same. So I'm going to open up the trash, and we're going to set a collision event for the hero. So what that means is we need to create a rule. And in this case, we're going to check for a specific event, which is an overlap or collision. Which type of actor do we want to collide with? It's the hero. And what should happen if there's a collision? Well, in this case, we want to destroy the trash. Very simple rule. If there's a collision with the hero, destroy the trash. Let's try it. Boom. That trash is gone. Take that, trash. All right, that's great. That'll do for the moment. Last thing we need, of course, is the roaches. And this is the other interesting thing about this game. If you watch the finished version again, you can see the roaches are moving in at least a somewhat interesting way, which is they're patrolling around the trash. So we need to think about how we would achieve that. And we can tell that the roaches seem to be moving at the same speed the whole time. They're just changing direction when they get to the corners of the path. So how are we going to bring that off? Well, first thing we'll do is throw a roach in. That's the only time I'm ever going to say that phrase. And doesn't do anything yet. It has no behavior, so let's give it some movement behavior. And this time, since we're not clicking, and we're not giving it a specific destination, we can use that move behavior. And I'll run it, and it just shoots right off the screen. That's a little fast, so I will go ahead and slow the roach down. And I'll also do the same for the hero. So I'm changing both of their speeds to 100, just because the area is pretty small, so they don't need to move so fast. And now if I run the game again, you'll see the roach is slower, but he's still just moving in the one direction, and that's no good. And the reason he's moving in the one direction, of course, is because the direction is specified as 0 degrees, which is straight to the right. So how are we going to make the roach change direction? Well, we have a few options. We could try to do something with collision, like we could say maybe there's some invisible obstacle. Look at this, I'm still trying to perfect this. We could say there's some invisible obstacle here, and if the roach collides with it, then he should change direction. Or we could do other things, like, for example, time. Maybe we say on a certain interval it changes direction. Although that doesn't solve the initial problem, which is how we're going to change the direction. But let's go ahead and decide on time. We don't really need to use collision because this is a square, and so it's going to be pretty simple to specify a time interval. And we'll just say that every so often the roach should change direction. So how are we going to do that? Well, the initial trouble that we have, of course, is that direction is specified as an angle, which is 0 degrees. And that's fixed. We can't change that once the game is running. So we can't set the angle initially with a specific number. We need something that we can control and change during gameplay. And if you've paid attention, then you can probably guess what I'm about to say, but we need to create another attribute. And in this case, I'll go ahead and create it in the roach's attributes. So here's the plus button again, and I'm going to create another integer, and we'll use this to control the angle of motion. So I'll call this direction, and it starts out at 0 degrees, and that's fine because we want the roach to move to the right first. And then up here, we need to change the 0 degrees to be our new attribute. So I put that in the roach's attributes, so choose roach, and then double click on direction. Okay. And now, right now, if I run it, it looks exactly the same as it was before. Because yes, we're using our own attribute, which is direction, but it's set to 0 degrees initially, and that's the same as we had there before, so there's no difference. But there will be a difference because we can change direction, our attribute. Now, we said we wanted to do this on a certain time interval, so we can use this behavior called timer. I'll drag a copy in. And by default, it says every so often, which is 5 seconds. What do we want to do? We want to change the value of direction to be different so that the roach will move in a different direction. So we need to use our old friend change attribute. And what do we want to change? Well, you should probably be able to tell me, but we're going to change roach direction. Now, what are we going to change it to? Here's where we get mathy. So put your math belt on because this is a math party happening up in here. Think back to geometry class, which hopefully you took. But if not, I'm going to give you a refresher right now. The angle of motion is measured against the x-axis, which is this one right here, going to the right. So if you think of the angle as being drawn between an imaginary line going this way, and then like this here, the space between the imaginary line and this is the angle. That's weird, I know. It would help to have graphics. But anyway, 0 degrees is flush with the x-axis. And then a right angle, which is 90 degrees, that's straight up. So that's going up in the y-axis. That's 90 degrees. And then directly to the left, so you're basically making a flat line, but it's going to the left instead of the right. That's 180 degrees. And then going straight down is 270 degrees. So think of it in terms of a circle. If you start here and straight to the right is 0 degrees, and then you like draw a circle going counterclockwise. Here's 90 degrees, and then 180, and then 270, and then back up to 360 degrees, which completes the circle, so it's the same as 0 degrees. If you need more help than that, consult a geometry teacher. But that's the idea. Now the thing is, here we don't want the roach to move clockwise. We want it to move, we don't want it to move counterclockwise, which is how angles grow by default. We want it to move clockwise. And a shortcut for that is you can use negative angles. Negative angles sound kind of weird, like how can an angle be negative? But all it means is that that circle that I was describing that grows like this, it grows in the other direction. So it grows this way, which is clockwise. So negative 90, instead of being straight up, is straight down. And negative 180 is straight to the left still, but negative 270 is straight up instead of straight down. So what's the mathematical difference between 0, negative 90, negative 180, negative 270? It's 90 degrees each time. So we need to subtract 90 degrees from direction every interval. Okay, the math part's done. Hopefully you follow along with that, but we need to apply that now. So what do we change direction to? Well, we changed it to its current value, so that's roach direction, but then we subtract 90. And that's as simple as typing minus 90. And that'll happen every interval. Now, if we run that, we're like, where's the directional change? It's going off the screen. Oh, it went off the screen. It doesn't mean we did anything wrong. It's just that 5 seconds is so long, the roach gets off the screen before he changes direction. So we need a shorter time interval, and 1 second should be about right. Let's try that. Perfect, look at that. So now this timer is counting up to 1 second, and then it's subtracting 90 from direction. So direction is going from 0 degrees to negative 90 to negative 180 to negative 270, and then back to 0. And just take another moment to appreciate what we've just accomplished. Again, we have given the appearance of the roach patrolling the dirt path. The roach actually has no awareness of these dirt tiles. It has no way to tell that there's anything different about the graphics here than down here. But we've made it look as though it does. We've made it look as though the roach has some intelligence. And we've done that just by utilizing timing and directional changes in a clever way. So you're going to do that a lot in your game design and development. It's just thinking about smart ways to achieve interesting effects. And you can play with this interval. You can use decimals to some degree if you wanted to, so you could do 90.98 seconds instead of 1. Feel free to play around with that until you get exactly the timing that you want. You can change the roach's speed too, of course. Alright, so that's great, but there's no collision, so right now the roach is not much of a threat because the hero is just, laughing at it. It's not posing any threat whatsoever, so we need to change that. This is going to be the roach is as big as he is. Come on, this should be dangerous. So now we need to do a collision event between the hero and the roach. And I'm going to do that in the hero, so open up the hero again. And again, this is just like with the trash. So you create a new rule, and then what should happen? The actor should receive an event, overlap or collision, but now the actor of type should be roach. So if the hero collides with the roach, and I'm going to destroy the hero. Let's try it. Works. And because it's sort of annoying that the game is just sitting there after I lose, I will make a reset game event as well. So for that, I'll go into the roach, and we'll do a collision event. It's going to be the same system as with the hero, at least with the setup. So collision or overlap with actor of type hero. But now, we'll reset the game. And if I try that, I'll see it works, but it's very abrupt. It starts right again, and that's sort of jarring, and it doesn't help me appreciate what just happened. It may be too fast. So for that reason, it's smart to put a little bit of delay in between the collision and the reset. So for that, I can use the timer again. I'll drag the copy in. And now I'm going to make it 2 seconds, so it's not quite so long. and put the reset game in there. So now this says if there's a collision with the hero, count 2 seconds and then reset the game. If you try that, hero's destroyed, count 2 seconds, but nothing happens. And the reason nothing happens, again, is if you remember your logic, rules only, or behavior inside a rule only applies when the rule condition is met. And that collision with the hero, it only happens for a moment because the hero destroys itself right away. So the timer, it never gets to 2 seconds. It starts counting, but then the collision goes away because the hero destroys itself. So it never reaches 2 seconds and it never resets the game. But of course we can use run to completion, just like we did before. And now if it starts counting up to 2, even if the hero is destroyed, it still finishes counting to 2 and it resets the game. Only it didn't in that case. Why didn't it? Oh, because this still says every. We need to do after. So after 2 seconds. So you'll just have to trust me that the previous way would not have worked. But now it works. Run into the roach, 2 seconds later, game resets. This is great. We're very close. But although we have a way to lose the game, we have no way to win the game. There's no real way to collect the trash because GameSalad is not counting how many trash bags there are and how many we ran into. We need to implement that, which means we need a way to count the trash. So let's do that. So for that, we're going to need to create another attribute. So for this, I'm going to go into the trash bag. No, I'm not. Actually, I'm not. I'm going to go up here outside of any actor and make sure the game tab is selected. And then I'm going to create a game level attribute. So there's the plus. This is going to be an integer. And I'll call it num trash for number of trash. And you'll see why I created it in the game level in a moment. So now if we go back to the actors, open up the trash bag again, we need to add 1 to num trash for every trash bag. So it's counting how many trash there are. And for that, we just need change attribute. And we'll change game num trash. What do we change it to? We change it to num trash plus 1. So whatever its current value is, add 1. And then green check mark. And this behavior, because it's outside of any context, it will only run once, right when the scene loads. So it's counting the trash. And you can probably guess we want to do the same thing when we destroy the trash, except we're going to subtract 1. So we can copy and paste this behavior, which is what I just did. I used my computer's copy command, and then I clicked in here and I did paste. And I can change this from +1 to -1. And that's our counter right there. It adds 1 at the beginning, and then it subtracts 1 when a trash bag is destroyed. But we're not doing anything with that yet. You know, if we play the game, we won't see any difference because we have to use that number. So what do we want to do? We want to make it so that if you collect all the trash, you move to the next level. What next level, you ask? We don't have one. Great point. Let's add a new level. To do that, click on the Home button. Make sure the Scenes tab is selected, and then click plus to add another scene. So there's a new scene. And I'll go ahead and just throw a hero in there just so we have the minimum, but it'll look different, so we'll be able to tell that it's a different scene. Maybe this fly, just to be threatening. Ooh, it's a fly. Okay, and now we'll go back to the first scene. And how we're going to do this, we'll go ahead and let the hero control this. What we want to do is check if he's collected all the trash, and then go to the next level. And how do we know if he's collected all the trash? Well, remember, num trash gets 1 added every time for every trash bag that there is, and then 1 subtracted for collecting every bag. And so there are no more bags if num trash is equal to 0. So that's what we need to check for, and we can make a rule for that. And in this case, we're going to check attribute. Which attribute do we want to check? This is why we needed to create num trash in the game level instead of inside the trash bag, because we only have access to game level attributes, devices, and the hero's attributes. If this were in the trash bag, we couldn't read its number. But because it's in game, we can choose num trash. That means the hero has access to the value of num trash. So what are we checking for? We're checking for if it's equal to 0. And if it is equal to 0, what do we want to do? Well, that probably means the player's beaten the level, so we want to move to the next level. And there's a behavior for that called change scene. Let's try that out. All right, so I'm gonna go for it. Go for it. I got both of them. Hey, there's the new scene. Awesome. And this fly, can't even hurt me. Although maybe it can't hurt me because it's on the ceiling. But anyway, if I reset and then I run into the roach, then I lose, and then the game resets. But if I get both of the trash, it goes to the next level. And you'll see too that if I if I die, no, if I there's no death, you just lost. If I get one of the trash bags and then I lose the hero, the game restarts, and both of those bags are back, and it still works if I get both. I go to the next level. And believe it or not, that's it. We now have all the components of the game. We have our hero and our enemy with their different movement systems. We have our environment, and we have our collectibles and the additional background element of the dirt. I forgot to mention, by the way, when you're placing elements to build out your level, you might find that you accidentally click on the grass really easily, by the way. Just because it's so big, it's hard not to click on it, and that can be really annoying. One thing you can do is you can move it off the field while you're building out the rest of the scene, and then once you're done, move it back. There's nothing wrong with doing that. It's a smart move, so I recommend that. But the point is, you now have all the components. So the tutorial is done. And we can just have a few more quick notes. Your challenge is to build out a 3-level version of the game. So you want to do something a lot more interesting than this. This is pretty boring, but you want to build out full levels. So you can take a look at the versions on the website for inspiration. You can see even within this confined area, there's still options for creating interesting level layouts. So let's talk about a couple of quick tips for level design. One thing is, obviously, even though the dirt is purely aesthetic, it makes the level interesting and it suggests paths. So you can create lots of interesting paths that way just using the dirt. And so the first thing you want to do is just create lots of different level layouts. But then after that, you can try creating tension with your level layouts. And what I mean by that is this enemy on its own, it's not very threatening because it moves slowly and I have lots of room to avoid it, so I can move in at my leisure. But if you look at this level, it's the same enemy here. It's still moving slowly. But because it's in close proximity to additional enemies, now I have to split my attention between all of them and be much more careful in my movement. So that increases the tension. And similarly, there's escalating difficulty in this level just within the same level, because some of these trash bags are easy to get, but some of them are much harder. And the more time I spend collecting trash, the more risky it will be to collect the rest of it, especially the stuff in the middle. So that's very effective. The other thing you can do, of course, is create new enemies and movement patterns. You can see some of these roaches are faster, and you've got the fly moving in its own funky way. Other than that, you could implement a time limit or something like that. You could add new mechanics. You could add sound. Sound is always important for creating a good feeling of a game. You could think about new mechanics, like I said. Like maybe you have to actually get rid of the trash once you've picked it up. Like maybe there's a recycle bin. You could have this crossover with the drop cycle game that hopefully you already made in another Activate tutorial. And the final thing is to think about the advantages and disadvantages of these movement systems, or the one for the hero. This is great for moving units across a pretty big space. That's why it's good for strategy games. And this area is still pretty big relative to the size of the hero. So this is a useful way to move him about. We don't have to move him every millimeter with arrow keys. But it wouldn't be so good for an action game where you need a lot of precision, because we don't have that here. And that contributes to the tension of the game. But you want to keep in mind the limitations and the strengths of your control system. And that is it. So I urge you to go ahead and make your remaining levels and have fun playing around with this mechanic in GameSalad. Check out some of the other tutorials that we have, and move on to the advanced tutorial, which will be coming along. And thanks so much for watching. Bye for now.